Hello students, I'm your tutor Syed. Today we'll try to take a very simple example. Let's get started. The question is, show that the vectors are mutually orthogonal. Three vectors are given, A, B and C. So under what condition these three vectors will be mutually orthogonal? To show that these vectors are orthogonal, we should have the inner product space to be equals to 0. The inner product space of two vectors should be equals to 0. Now how to show that the inner product of these two vectors is equals to 0? Let us try to take these two vectors A and B. So vector A, which is given over here as 2, 0, 0, 0. So each of the element can be taken as A1, the next element as A2, A3 and A4. So 4 values are there, 4 elements have taken. B is equals to, you have 0, 3, 3, 0. And corresponding elements for each of these values can be taken as B1, B2, B3 and B4. Now if you try to take the inner product space AB, then I have to take the product of each of the elements from A as well as from B. So it will be A1, B1 plus A2, B2 plus A3, B3 plus A4, B4. Now let us try to plug in these values. A1 value is 2 and B1 value is 0 plus A2 value is 0. So these are the corresponding elements that I am taking over here. So this is A2 value. Then you are having B2 value. A2 value is 0 into B2 value is 3. Then you have A3 to be equals to 0, then B3 to be equals to 3 plus it is 0 into 3 plus A4 value. So A4 value is 0 into B4 value is also 0. This will be equals to, you can observe that 2 times of 0 is 0, 0 times of 3 is 0, 0 times of 3 is 0. So 0 plus 0 will be 0. So hence we have got the inner product of AB to be equals to 0. Therefore, you can say that A and B are orthogonal. A and B are orthogonal. But he says that, show that the vectors are mutually orthogonal. That is not just A and B, corresponding other vectors which are there over here. That is B and C are also orthogonal. Then C and A are also orthogonal. Then we can say that A, B and C are mutually orthogonal. So we have taken the first combination AB. Next we'll go for the next combination B and C. Now let us try to take B. The vector B is 0, 3, 3, 0. And what is C value? C is 0, minus 1, 1, 1. Now I have to show that the inner product space BC is equals to 0. Now if you try to observe, this corresponds to your B1, B2, B3 and B4. And over here, this corresponds to C1, C2, C3 and C4. Now if you write down the inner product of BC, that can be written as B1, C1 plus B2, C2 plus B3, C3 plus B4, C4. Since all the values are known, we need to just plug in. So B1 value is 0, C1 value is also 0, plus B2 value is 3, C2 value is minus of 1, plus B3 value is 3, C3 value is 1, B4 value is 0, C4 value is 1. Now let us try to multiply this one. The first term is 0 times of 0 is 0, plus into minus is minus 3 you'll be getting, plus 3 you'll be getting, the last term is 0. But we observe that this minus 3 and plus 3 will get cancelled. We are left out with 0. So hence you can conclude that B and C are orthogonal. Therefore, B and C are orthogonal. But further, we have to take one more combination, that is C and A. So if we try to take CA, the inner product CA is equals to 0. So we know C value is how much? C is 0, comma, minus 1, comma, 1, comma, 1. So this is nothing but your C1, C2, C3 and C4. Then you have vector A, that is nothing but 2, comma, 0, comma, 0, comma, 0. This is nothing but your A1, A2, A3 and A4. Now, if I try to take the inner product CA, which will be nothing but C1A1 plus C2A2 plus C3A3 plus C4A4. Since all the values are known, just plug in all the values. C1 is 0 into A1 is 2, C2 is minus 1, A2 is 0 plus C3 is 1, A3 is 0 plus C4 is 1, A4 is 0. So you can observe that each term is having 0, 0 multiplied by anything will be 0 itself. So each of the term is 0, hence we get the value to be 0. So therefore, what is the conclusion here? The inner product C and A is equals to 0. Therefore, we can say C and A are orthogonal. So now if you try to observe over here, we have shown three combinations over here. One is we have shown AB are orthogonal. Then we have shown BC are orthogonal. Then we have shown C and A are orthogonal. So you can conclude from this, therefore A, B and C are mutually orthogonal. They are mutually orthogonal to each other. So that's the conclusion you can draw. So that will be the required solution. So the problems are very easy. You can solve it very easily. So try to work on more problems so that it becomes very simple for you. So that's all I have in this session. Meet you in the next session. Till then, goodbye.